In this capstone, you'll design a trust architecture for AI-enabled enterprises. The goal is to connect identity, provenance, deepfake resilience, cryptography, and governance into a practical blueprint for automation, compliance, and future digital trust. So far, you've examined how AI changes the enterprise, how risk and security must adapt, and how governance creates assurance. Now we bring those pieces together into a future-ready trust architecture that supports sustainable transformation and long-term confidence. The enterprise is moving toward an AI operating model where software agents can act, transact, and make decisions. That changes the trust problem. It is no longer only about human users. Workloads, APIs, certificates, secrets, keys, models, and content all need identity, governance, and proof. Your challenge is to design for autonomous AI, machine identity sprawl, deepfakes, content provenance, and the shift to post-quantum cryptography. The target state is an enterprise trust model that treats AI as part of the operating environment, not as an isolated tool. Every interaction needs clear trust boundaries across people, agents, applications, APIs, workloads, devices, data, and content. Policies then drive proofing, authorization, provenance, monitoring, and attestation. Most importantly, verification is built into the workflow, so evidence is produced continuously. That is how governance, security, modernization, and crypto agility become one repeatable architecture. An AI agent should never be treated as a generic automation account. It needs a named identity, a clear owner, and a defined purpose. Trust is then built in layers: scoped permissions, controlled tool use, approval thresholds, continuous monitoring, and a complete audit trail. If the agent acts outside policy, invokes risky tools, or requests unusual privileges, the system must detect it, constrain it, and escalate to a human. Machine identity governance begins with visibility. Every certificate, key, token, service account, workload, container, bot, and AI agent needs an owner, purpose, privilege level, dependency map, and expiration date. From there, automate the lifecycle: issuance, rotation, revocation, attestation, and decommissioning. High-privilege services and production agents require stronger controls. Telemetry should also feed security operations and compliance evidence, so machine identities are governed continuously, not rediscovered after an incident. Verifiable credentials act as portable proof for enterprise trust. An issuer, such as HR, a certification authority, or a model governance board, creates a credential against an approved schema. The holder presents only the needed claims using selective disclosure when privacy matters. A verifier checks signatures, trust registries, and revocation status before granting access, approval, or data use. The same pattern can authorize people, AI agents, systems, and data sources. Provenance helps an organization keep AI-created content trustworthy after it leaves the model. The process starts by identifying the source: AI-generated, AI-assisted, human-approved, or external. Controls then capture metadata, apply signatures or watermarks, and preserve tamper-evident records. Before publishing, legal and policy review confirm labeling, rights, and approval. After release, verification and tracking support customer questions, misinformation response, and accountability if something goes wrong. Deepfake resilience is not one control. It is a chain of decisions. Start by identifying scenarios that could cause real harm, such as a fake CFO voice approving a wire transfer. Reduce exposure through policies and trusted channels. Detect suspicious media with tools, provenance checks, and behavior signals. Verify sensitive requests out of band before acting. If an attack succeeds, preserve evidence, escalate to legal and security, contain the damage, and communicate quickly to protect trust. Post-quantum readiness starts with discovery, not replacement. Build a cryptographic inventory across certificates, TLS, VPNs, code signing, identity, databases, APIs, and embedded systems. Then classify each dependency by data sensitivity, expected lifespan, exposure, and migration complexity. The key risk is harvest now, decrypt later, where encrypted data stolen today becomes readable in the future. Prioritize trust anchors: identity, regulated data, critical infrastructure, and external integrations, because failures there can cascade across the enterprise. PQC migration should be managed as a program, not a simple swap. Discover where cryptography is used, assess exposure, prioritize critical systems, pilot post-quantum options, transition in waves, validate, and keep monitoring. Crypto agility is the goal. Modern PKI, automated certificate lifecycles, flexible key management, and enforceable policies. During the transition, hybrid cryptography can bridge traditional and post-quantum protections, while governance controls algorithm approval, exceptions, vendors, and compliance. An enterprise digital trust framework turns scattered controls into an operating model. Begin with principles. Verify explicitly, reduce implicit trust, prove provenance, automate evidence, and stay adaptable. Then map the trust domains across people, machines, agents, data, content, cryptography, and operations. Ownership is critical. Architecture, security, IAM, PKI, AI governance, legal, compliance, procurement, and business teams all have roles. Finally, measure trust continuously, from posture and credential adoption to machine identity hygiene and post-quantum readiness. Modernization is a sequenced portfolio, not a single program. Start by stabilizing foundations: IAM maturity, PKI, API security, telemetry, and governance ownership. Then build outward into identity modernization, machine identity controls, verifiable credentials, agent trust, and content provenance. Longer term, add operating model changes, assurance metrics, and post-quantum readiness. The roadmap should tie every milestone to risk reduction, business value, funding assumptions, and the executive decisions needed to maintain momentum. Your capstone should feel like an enterprise-ready architecture package, not a set of disconnected artifacts. Start with clear current state assumptions. Then define the target trust model, control objectives, owners, risks, dependencies, and success metrics. The evaluation focuses on whether your recommendations are complete, traceable to real risk, feasible to implement, and aligned with governance. Strong work connects technical choices to resilience, compliance readiness, executive decision-making, and a practical roadmap for long-term digital trust modernization. The big takeaway is that AI trust is not a single control. It is an integrated architecture across identities, agents, credentials, provenance, resilience, and quantum readiness. Your next step is to turn the capstone outputs into an executive-ready transformation portfolio, prioritized by risk, feasibility, impact, and regulation.